All right, hey folks. I'm Patrick Donnelly. I work primarily on CephFS for IBM, although that's not the topic of conversation today. But feel free to stop me outside if you want to chat about CephFS at all. Today I'm going to be talking about SQL on Ceph. Which is a provocative title to get people in the room. I'm really going to be talking about SQLite on Ceph, which should also be exciting, but maybe is not the distributed SQL you may be thinking of. We'll talk about that more later. So here's a brief outline of my talk, but while people skim that, because I don't need to read it to you, who here has used RADOS? Okay, who's actually used Librados? Oh, okay, just a few people. And who here has used SQLite? Okay, so lots of people. So we should all be pretty excited about that. This slide is fairly famous because it's almost in every Ceph developer talk. Very exciting. We got our three pillars of Ceph. They all talk to Librados. That's what they have in common. But did you know the Ceph manager also talks to Librados? Very exciting. Yeah, so the Ceph manager does many operations on Librados, anything that needs to be persisted. Some things are also stored in what we call the monitor config store, which we use for a super reliable store that has to operate even when RADOS is inoperable, especially in like early bootstrap stages of a cluster when we don't even have an OSD yet. But for some things, we can just persist directly to RADOS. So let's talk about the Ceph manager design. Dan talked about it earlier. We now have this magical way to run Python and Ceph as part of that manages cluster operations. We have these different modules, so everything's abstracted into a Ceph manager module. These modules take care of things like orchestrating daemons, orchestrating upgrades. Ceph ADM is partially a Ceph manager module. We have a dashboard now. We have a way to monitor the device health of our OSDs. And these are all just several dozen manager modules we have, and you can enable or disable them as needed. Some are default and can't be disabled. In general, the manager has no dependency on CephFS, RGW, or RBD. And that's a deliberate decision because we want the Ceph manager to operate even if those services are not available. So that's one of the reasons why, as I alluded in my previous slide, the manager also talks directly to RADOS. There are still some manager modules that do talk to things like CephFS. So if they have the volumes plugin, that provides a higher level interface for doing things like creating subvolumes or even creating file systems. That actually does talk to CephFS. But generally, it's a standalone daemon. So what does it provide? It provides basically a glue for Python and Ceph. Lets the manager modules talk to things like the Mon client, get access to the monitor maps, OSD maps, and then also some of the modules even need to use Librados for persistent state. What's an example of such a module? We have the device health module. So that's going to slurp up all the smart data from all the OSDs and persist that out to RADOS. And that's basically all it does. It provides a CLI interface for other modules, namely disk prediction, to allow us to predict future failures of devices. So it's a fairly simple module, but one of the things it was doing is that it was basically using Librados to store all of this data. And if anyone here who has used Librados knows, it's not really the most programmatically friendly library. I mean, it's a good library for doing distributed storage, but it forces you to think about things that are rather difficult problems, things like consistency or how do I scale out, right? These are not really things that you want to spend time doing in a language like Python. So this is where SQLite enters the picture. For those of us who have not used SQLite, it's an application library that allows you to store a SQLite database as a regular file. So a single blob of data. It's known for being, especially if you go to their website, it's known for being one of the most used SQL database engine in the world. It's on everybody's phone. It's on almost every computer that's deployed in the world. It has a very rich C API, allowing us to embed it and also extend it. And then another highlight of SQLite, which was one of the reasons I was looking at this at all, was it has an easy binding for Python. And of course, now we have Python and Ceph in the form of the Ceph manager, so let's see if we can bring these two worlds together. The way we actually do that is through the SQLite VFS. And that, at the beginning, only provided access to what's called the Unix VFS, access to the Unix file system, or any file system, local file system. So what does that do? It's just a part of SQLite that abstracts all of the open, creates, reads, writes, syncs into a single library that can be swapped out for something else. So if you don't provide a VFS, it defaults to Unix. So if you use SQLite on the command line, that's what it's going to be doing, is putting in a regular file on your system. What does it actually look like? We have two. It actually ends up creating two files, the journal and the database. The journal is usually deleted by default, so you don't ever see it if you do an ls after interacting with your database. But there is actually two different files that we care about. So, enter libcephsqlite. So SQLite is a VFS that allows you to stripe a SQLite database over RADOS. The real highlight of libcephsqlite is it doesn't require any application modification in order to use it. You just have to load the SQLite dynamic library and specify an alternate URI for your database. So again, the journal and the database are automatically striped over the OSDs. You don't have to think about it at all. You just use your SQLite database like normal. How this actually works is on a new library called Simple RADOS Striper. This is just a simple interface that allows us to stripe a variable sized blob onto a number of objects. This is something we're already fairly good at doing with Ceph, CephFS files, RBD images, RGW objects. These are things that get striped over multiple objects. Similarly, we're going to do the same thing for the SQLite database. This is conceptually based off of a CERN library. Where's Dan? Oh, Dan. Librados Striper, which was developed by CERN. Unfortunately, I couldn't use it because it does a sync on every, or it does reads and writes all synchronously by acquiring a lock. I was very sad about that. So instead of ripping the rug out from under them by trying to modify it, I just wrote a very simple version of it that I called Simple RADOS Striper, tailored for libcephsqlite, mostly to allow for very asynchronous writes. So again, Simple RADOS Striper provides all these primitives that we use: open, read, write, sync, close, and it stripes all the data over these objects. You can actually use the RADOS client, the CLI client, with the striper option to read and write these databases out of RADOS. So it's actually compatible with the librados striper that's already in Ceph. So if you want to use libcephsqlite, what do you have to do? Again, I told you you don't have to modify your application. I wasn't lying. You do have to tell Ceph or SQLite to load the VFS. That's done through a special SQLite command .load. You just specify the Ceph SQLite library, and away it goes. It loads it up. And then you open the URI associated with Ceph SQLite, which involves specifying a pool ID, a RADOS namespace in the pool, which is optional, and then the name of your database, and then the VFS, which would be Ceph. That's all there is to it. There may be some, depending on your situation, there may be some environment variables you may need to set, namely like where the Ceph conf is, or any additional arguments you want to specify. If you want to use a particular credential in your keyring for your Ceph SQLite, you would use Ceph args for that. So the Ceph manager, as of Quincy, is now using libcephsqlite. Probably didn't notice, I hope, unless something crashed, and then I'm sorry. So it's the way this works is the Ceph manager now has a uniform interface for interacting with a SQLite database that's associated with every manager module. So every manager module can just automatically use a SQLite database. It doesn't need to be tailored at all to do that. We have this. We also now have a .manager pool, which some of you may have noticed. It was actually in the previous talk. You can thank me for that. It used to be called the device health pool, but we just generalized it to be the .manager pool and be used by all the manager modules. Hopefully your upgrades went well when that rename took place. The actual access within the Ceph manager you can see on the right in that code snippet is fairly simple. You just specify your SQL statement as you normally would when using SQLite within Python. And then you have to acquire a database lock in case you have multiple threads within a manager module all accessing the database. You have to synchronize on a lock, which is provided to you. And then actually create a transaction within the database by specifying the database in the with statement. And then finally, you just execute the SQL. And then I can do things like read out the data with, and this is a simple generator, which is doing a select on B from foo, where A equals question mark A is provided to the function F. So we're reading all the columns B in that table. Let's see what else. So everything else is abstracted away. Where is the data? So in all of these manager modules, the database that's associated with each module is just called main.db. There's also a main.db journal file. As I said, the SQLite has a journal file associated with each database. And then in the .manager pool, there's a namespace named for each manager module, and then a number of files, objects for each given database blob, main.db or main.db journal. So that's what you'll find there if you did a RADOS ls there. The device health module. So now the schema is fairly simple, but I didn't talk about earlier, forgive me, the device health module, what it would do is it would create an object in RADOS named after the device that it was collecting health for, and then it would use the OMAP key values to store a series of smart data dumps in the OMAP. So now this is all just transferred into a very simple schema for keeping track of the devices and device health metrics. So we got a single table which gives us the device ID. It's a very simple table, and then the device health metrics, which gives us the timestamp of when the sample was taken, the device ID associated with that sample, and then the raw smart text. And then the primary key for that table is the device ID and the timestamp. And so I can do complex queries to look up a series of smart data dumps, and then also I can, like, if I'm trimming the journal, or the database, as part of routine garbage collection, I can do very simple delete statements as well. And then this is an actual snippet of real code from the manager module. I just took out a few keywords for horizontal space, but otherwise this is basically exactly the code. If I'm putting a device metrics into the device health metrics table, I am going to first create the device ID if it doesn't already exist, create an epoch associated with the timestamp, and then the third step, json.load, that's where I'm loading the data dump, make sure it's valid. It should be, otherwise it's going to assert. And then I'm going to insert it into the table. And it's really that simple. So it looks like normal SQLite code in Python. So I don't know why the GIF already started, but it did. So this is libcephsqlite in action. Wisely or not, I tried to do the tutorial and then record it. But so this is a Ceph status. Here I'm just listing the pools. You can see the .manager pool, and then I'm purging it, so I'm deleting everything in it. And just verifying that there's nothing in it by doing an ls with the all keyword that looks at all the namespaces in the .manager pool. There's nothing there. It's just setting the stage for the next part. So here I'm going to actually run SQLite 3 command line tool to put a database in Ceph. I'm doing this within a developer environment, so I'm setting a number of environment variables, namely where to find the libcephsqlite library. It's in my build directory. I have to tell it where the Ceph comp file is, which keyring I'm going to use, and then which credential I want, which is the admin credential, which obviously is a developer would tell you don't use that in routine operation. You can also specify some debugging flags in the Ceph args if you want to look at some of the debugging. So here I'm just loading the libcephsqlite library. That's the first command to SQLite 3. And then I run another command to open the database file. So I'm going to put it in the pool A in namespace B, and the database name will be a.db. I'm creating a simple table with integer, a single integer column. And I'm inserting one value into that table 1. So I'm just going to dump it, verify that the dump of the SQLite is exactly what I would expect. Leaving SQLite, now I'm going to do a RADOS command to ls all the objects on that pool. You can see in namespace B, the single database object a.db.0000. And then finally, as I promised you, you can use the striper command to actually slurp the database out of RADOS if you want to, which I did. And you can just have a look at it. It's 8 kilobytes, which is why it only took a single object in RADOS, and then did SQLite on that database, which is now local, and verified everything is as it should be. So in the next one, we have basically the same thing here. I'm just going to forgive its copy paste because it's just a lot of text, but this is basically a fancy way to create an infinite loop limited by the number of rows to insert a number of random integers into this table. And you can see that at this point now, the table is large enough, we have a database that spans 4 objects. And as a user, as an application writer, I didn't have to think or care about the consistency of having several objects associated with my data set. That's the selling point. All right. So unlike my FOSDEM version of this talk, I have a little bit of time to actually talk about some performance notes. So a lot of this is already dealt with in the Ceph manager, but if you're thinking about using this object yourself, you want to play with it, there are some caveats as performance-wise to actually squeeze out the most performance you can with this library. It's all documented in the documentation, which is at the bottom. Hopefully the slides will be available at the end of the Ceph day. If not, you can always email me to get a copy of the slides. But basically, there are a number of things you have to control in order to get the maximum performance. One is the page size. The default page size in SQLite is very small, which results in excessive reads and writes to the backing OSDs. I recommend raising that as high as possible. I believe I use 64K in the manager. Keeping in mind that a single object can be 4 megabytes, so you want to kind of maximize the amount of, or reduce the number of IOPS involved with your use of SQLite. Sorry, that screen is too small for me to read. You want to use a larger cache size, so reading to avoid reading from RADOS. So there's no cache in simple RADOS striper deliberately. Instead, use the SQLite cache instead, and the way you can get more cache is telling SQLite to use more cache. You want to persist the SQLite database, so you'd want to avoid deletion of the objects associated with like the journal for the SQLite database if you can. So that's one reason we would that would be why we would persist it, to avoid those unnecessary operations. You want to use exclusive locking if possible of the SQLite database. That can reduce your transaction latency from 5 to 3 operations per transaction. So normally when I do enter a transaction in SQLite, I have to lock the database and then do some reads and writes, and then finally unlock the database. If I enter an exclusive mode of operation, SQLite locks the database once at the start and unlocks it at the end when I close the database. So that can save you a lot of ops whenever you're doing a transaction. And then another optimization you can do is use the wall journaling in SQLite, which normally requires shared memory communication between clients of the database. But if you're using the exclusive locking mode, then you can you don't need to use shared memory. Instead, SQLite will allow you to use a wall journal without that. Obviously, if I'm using a SQLite database in RADOS, there's not going to be any shared memory communication between the clients, which could be anywhere. So if I do that, then you get the most optimal behavior of one operation per transaction, because I've got the database open exclusively, and I'm just writing to a wall journal in the general case. So that's going to get you 2 to 5 millisecond latency, depending on, of course, your cluster. If it's Dan's cluster, it could be up to 155 milliseconds. Reads are synchronous. That's really unfortunate. That's just baked into the design of SQLite's VFS. I've complained about it. It's actually, well, it's not on this slide. It's a link on the next slide, where there's not really anything I can do about it. If SQLite does a read through the VFS, it's a synchronous read out to RADOS. Ideally, we'd be able to do asynchronous reads, and then SQLite would do a gathering at the end. I think I know what you're talking about, but it's not the right thing. Not for reads. But we do asynchronous writes out to RADOS. Yeah, so the retrospective on SQLite VFS, the end of this slide, is where I rant at the SQLite developers about the VFS. It was mostly positive things to say, but there were a few gotchas that I found along the way. Right now we're using it in the snap schedule and device health modules. It's limited use so far in the other modules. Hopefully going to make improvements to that, maybe by publicizing more. But for example, it would be nice to use in telemetry to keep track of reports that a cluster has used in the past. We did have a few bugs. Most of them were related to like some packaging. There was one GCC static compiler error. I'd add a RADOS destructor a destructor to the library to avoid a bug we found in unit tests. And then there is one outstanding bug which has tripped up a number of clusters. It's not really debilitating, but if we lose the lock on the database, perhaps because there was a short network partition, and so the library was not able to renew the lock in the background, then it automatically blocklists itself to protect the integrity of the database, which means that whatever the module was doing, in this case device health, it can't continue doing. And the logic wasn't yet built into it to try to reconnect. So I'm actually working on a fix in progress for that that I'm hoping to release soon, so that the SQLite library, at least within the Ceph manager, can reconnect to RADOS, and then the module can pick up where it left off. So as far as future work, right now the library does everything under an exclusive lock on the database within RADOS, so that there's only ever one reader, one writer. That's not any architectural limitation. It's just something I need to address by adding support for multiple readers. And then read-ahead performance, which is related to the limitation in the SQLite VFS only allowing one or doing synchronous reads. So the only way to approach that problem from our end is to add read ahead, and that's going to require exploring how read ahead works in within the Unix context to see if I can reproduce the correct read ahead performance in Ceph, which will give us somewhat similar performance in that regard. We do have a libcephs SQLite, which was developed a year ago by a GSOC student. It does require a little bit of cleanup. It wasn't merged yet, but that's another library binding we would like to add. The main reason you'd want to use that over, like, say, put SQLite on CephFS mounted normally is then you don't have to actually mount CephFS. It's just SQLite on libcephs on Ceph. All right. I'm very confused why the slide's here. Oh, someone edited my slide deck, sorry. Those were appendix slides. There's my thank you and my contact information. There's a blog post concerning libcephsqlite if you'd rather see this talk again in text form, and the documentation, which also talks about all the performance notes I mentioned earlier. Any questions? Kyle?
SQLite backend on top of libsql on Ceph.
Sorry, what?
I'm mostly joking.
Okay.
There's a libsql backend for RADOS gateway now, and so you could wire the two together in an unfortunate way. But
I feel like Matt was behind this. Matt, is this your?
Well, Gal Salomon wrote that, but that isn't conventional. So the SQL engine inside of RGW performs SQL operations on tabular data.
Oh, I see. Not quite the same. Yeah?
Patrick, could I end up in large OMAP warnings with the setup as well?
No, there's no OMAP used by this. It's all just blob storage.
Okay.
And there's no chance of having objects that are too big either, because the objects are limited in size by the striper. Yep.
If I'm not mistaken, SQLite is pretty scalable in terms of size of how large a database can be. What's the largest you've tested it?
So I believe the architectural limit in SQLite is 480 terabytes. I've gotten up to a few terabytes before I stopped. I would not advise getting databases that size, because you'll start to hit, when you actually want to read out of the database, you're going to start hitting performance issues, namely because of the lack of asynchronous reads. So I would, by default, recommend, at least at this time, databases on the smaller side, and maybe more databases rather than one large database. Once you start wanting to go larger, I would start looking at things like Postgres, which may someday end up on Ceph. Any other questions? Cool. I'm under time.